Hello, everybody. My name is Matt Delacluse, General Manager for RAECO Rents. I'd like to thank all of you for taking the time out of your busy schedules to join us for measuring mercury vapor in safety critical applications. Our presenter today is Joe Pecha from Arizona Instruments. In this 45-minute free webinar, he'll cover the following: dangers of mercury exposure, regulations on mercury use, exposure and detection, problems faced by industries using mercury, understanding mercury detection and measurement technology, and ask the expert. Your questions will be answered. Joe Pecha, Senior Account Representative at Arizona Instruments, has nearly 20 years experience in sales and manufacturing. His main focus is helping customers get the best data and performance possible from their gas analyzers. Now I'd like to turn it over to Joe. Thanks, Joe.
Good morning. I'm here. Good morning, everyone. Let's see. We will start. Okay. So we're going to talk about the measuring mercury vapor in safety critical applications. I'll share some stories with you you'll probably like. And then we're also going to talk about how to measure mercury and what types of instruments are out there. Basically, this slide is showing the OSHA regulations, NIOSH, EPA, their exposure limits, and what they time-weighted averages. It's in micrograms per meter cubed. They always measure mercury in micrograms per meter cubed versus mercury in parts per billion. It's just an industry standard. It's always per meter cubed. Industry applications, we have power plants, usually the coal-fired power plants. Industrial hygiene, which is a whole array of different applications, includes dentistry, decommissioning of government plants, or any type of manufacturing where they might be using mercury. Gauges is one. Lighting plants, is another one. Although they're getting away from that because of the new types of lighting that are coming out. What's that called? The digital lighting. LED. Yeah, LED lights versus the CFL lights. Another industry, big one, especially out west here in Nevada, is the mining and coal industries. Coal back east, but the gold mines out here, they use a lot of our instruments. Hazmat, that would be fire departments, anyone with a safety department, for instance, a hospital that's still using the old blood pressure cuffs with the mercury in them. Sometimes they'll break, and then they have to call in their safety team to come in and make sure all is clear after the mercury's been lapped up. Dental, we talked about that. The dental industry, there are dentists out there still using amalgam fillings, and people aren't aware. I mean, my brother went to get some dental work, and so I said, well, what kind of fillings did you get? He goes, well, I don't know, silver. I said, silver? I said, that's mercury. And the dentists are just telling him it's silver, and it's not. It's amalgam. It's mercury amalgams. So it seems, back when I was a kid, I used to play with mercury all the time. We'd shine pennies with it. We'd spill it on the floor and break it apart, put it back together. But it is an invisible or odorless gas, and it can attack the nervous system. It's linked to autism, that's a big one. And let's see, what are some of the other brain, liver, kidney exposure? I know that Mad Hatter's disease came from people that were making hats. They would put the mercury on the felt hat to make it stiffen up, and that's kind of where that term came from, because these guys have been using so much mercury on these felt hats that it would make them go crazy, because it attacks your brain and so forth. We'll move on to the next slide here. Here we are. Okay. Let's see. So workplace health and safety, there again, dental offices, recycling facilities, I didn't mention that one, first responders we talked about, biomagnification, which is basically, when a coal power plant fires up their stacks, mercury goes out in the air, gets into the water, and then, of course, the fish eat it, and it carries on. But not only does it do it in fish, it also does it in plants. It does it in water, in the groundwater. I know that miners way back when they used to pan for gold, what they do is they would charge their pans, and how you charge a pan is you put mercury in it, you charge it up, and mercury attaches to the pan. But then when they're done, they throw that mercury into the water, and down the stream it goes. Emissions we talked about. The one that's not on here, geothermal is a big one in California, and also the gas and oil companies, natural gas in the pipelines. I know they monitor for mercury in those lines a lot. Let's see, what else? Let's go here. Okay, so I'm going to go, let's see, can you go back on this?
I think you hit right click.
Yeah, right click.
And then previous.
There we are. Okay, I'm going to talk about some stuff here that I think you'll enjoy. So some of the stories that I've had where they use mercury vapor is down in Florida, in the Key area, and in Miami area. I was told by some of the hazmat people that Haitians were coming over and they would have to test them for mercury. They would bring vials of mercury over. They'd have mercury in their clothes, in their hair, and the reason for this is because they would use it in their religious cult type offerings. They would use mercury in bones and things like that. They've even found the police department down there has found places where people would worship, I guess, and use mercury and old animal bones, and they'd rub it together, and they would see it. They would see the mercury when they found these bones, seeing if they're human or if they're animal and so forth. Let's see, what other applications are they using mercury? Let's see, we talked about the mining, the recycling plants, the CFL bulbs, some of the bigger plants, some of the bigger companies like Veolia, they have several recycling plants, and they monitor those very, very closely. So now we'll talk about the types of instruments that are out there. First one is atomic fluorescence spectroscopy. Basically, what that is, we manufacture that type of instrument. We can read down to 50 nanograms of mercury vapor in air. This is for elemental mercury. It doesn't do organic or inorganic mercury, but elemental mercury. And kind of how this works is there's a light source, and the light source inside of the instrument does have, it's a small mercury bulb, and the air passes through the tube, and when the light source turns on, it magnifies the, I believe it's the 254 electron that is in the air, inside of that mercury sample. And then a full little multiplier tube looks for those electrons and counts them. And as when it sees all of that, it counts them, and in an instant it says, okay, this is your measure of mercury, in your sample that you're seeing right now. So it's an instantaneous type of reading. Okay. The features of the 505, of course, the detection range we can read down to, this is 0.5, looks like micrograms per meter cubed. We can go down to 50 nanograms. The resolution, of course, is there. The precision, accuracy numbers. Response time is about 28 seconds. You can put the instrument, let's say you go into a building, and it's like, let's say a classroom. I've had them do them in classrooms, in schools. So you're going down the hallway, and you push the button, and you go, you put it in the sample mode, and you just kind of walk slowly, moving the instrument back and forth. And when you get a hit, you know that you're getting close to the mercury. At that time, you need to change it back to the standard mode, and just hit the button and take samples to find where that mercury source is coming from. You can do this in dental offices. You can do it in schools. You can do it in decommissioning of buildings and things like that as well. Battery life, 10-hour battery life, charges in 3 hours. The instrument's pretty lightweight. It's 6.5 pounds. We do manufacture a shoulder strap, satchel type bag that you don't want to carry that around so much, because it can get tiresome on your arm if you're looking in big buildings for mercury. It also does data logging. It'll log your samples. Interferences on this, we're not aware of any. I think acetone is one. It's pretty rock solid. If you're looking for elemental mercury, it's a pretty rock solid type of instrument. And I'll explain why it's a little better than atomic absorption in a few slides here. Let's see. Let's go here. So basically the functionality of the screen, everything on the Jerome 505 is flashed on the screen, and it also records the readings. You can set by the program menu on the top of the instrument. You can download the information. You can set it to different modes. Whether you want to do micrograms, milligrams, or nanograms. You can just change that right on the screen. It also allows you to enter where you are. Say you were going to do several locations. It will allow you to program to go in there and punch in and say, okay, I am at school, St. Mary's High School or something, or wherever it might be you're at. You can program that in there. Let's see. It holds all the information, and when you're ready to download, you just put your USB key or thumb drive into the USB port and download the information that way, and bring your thumb drive back to your computer, plug it in, and then you can view the information. And from there, you can manipulate it into a spreadsheet if you decide you want to do that, or you can just read it right off. Just print out the sheets as they come out. The next type of instrument that we manufacture here are the gold film sensors. Gold film sensors are they're different because they read elemental mercury, organic mercury, and inorganic mercury. They'll read it all. Basically, how this works is draws in a sample of air. It goes through a scrubber, and depending on, there's actually a solenoid that will open or close different air paths, depending on what the gold film sensor is seeing. So if it, and this happens all within a split second. So if the sample's coming into the instrument and it's high, that solenoid is going to click off and say, no, go through the scrubber first and then come back through the gold film sensors. That allows you not to flood the gold film sensor with too much mercury. With that being said, you actually could flood the sensor if the reading or the mercury vapor is so high. But anyway, so it goes over a gold film sensor, and what it does, it sends a charge through that gold film, and it measures the resistance of that charge from one end to the other. As it does that, by a Wheatstone bridge, it will go to a reference sensor on the other, basically on the other side of the substrate, and it will compare it. When it does that comparison, it will then do an algorithm and tell you your amount of mercury that you're seeing, in that sample. Let's see, I'm thinking of hydrogen sulfide. Let's see, it doesn't react. We do manufacture a hydrogen sulfide instrument, although this will not react to hydrogen sulfide because of the types of filters that are built into it. Let's see, what else? Here again, here's the features of the 405. We sell two different ones, one with data logging and one without data logging. Accuracy, response time, all of that is the same on either one. Battery life is the same. Field operation, that's all the same. Okay, so the next type of instrumentation out there is atomic absorption spectroscopy. What this does is it works close to fluorescence, but the reference cell actually takes a beam of light and it bounces it back and forth. So there's a longer travel time for the photomultiplier to see the sample of mercury that is in the air. Some of the issues that we found, because we did this once, we had a 471. We ran into problems with humidity. Humidity was a big one. We ran into a problem when we would ship these instruments if the mirrors that are inside the instrument, reflecting that light back and forth through that tube, if they got out of place or they got dust in them, you're out of cal. The whole thing would be, your readings would be way off. And so that's why we felt that the atomic fluorescence was better, because it just has one beam of light going right through it, and then one photomultiplier, and it's counting the electrons. So it's simple and easier to use. It also seemed to have less interferences just with dust and with humidity. If the chamber were to get flooded with humidity or mercury vapor on the atomic fluorescence, it would clear quickly. I think it's a 6 or 7 minute clear time, whereas on the atomic absorption, it takes a lot longer. It's hours to clear that cell because of the light path bouncing back and forth. Here's some comparison of the gold film, the atomic absorption, and the atomic fluorescence. Like I had mentioned before, acetone we know is 1 on the atomic fluorescence. The gold film sensor chlorine. Let's see, I know the mercaptans interfere on the hydrogen sulfide, but not so much in the mercury one. Same with the H2S, because we manufacture a hydrogen sulfide monitor, so the filters actually take those interferences out. So they're not so much of an interference. Ammonia is one on the gold film sensor. And let's see, we do have filters to remove ammonia interference or chlorine interference. You can use one or the other, but not both. You can't put them together because it creates an issue or a problem with some toxic gas. Let's see, atomic absorb some of the interferences. The chlorides, sulfides, I mentioned before, dust, and the moisture, humidity, things like that. For regeneration, that's kind of when your sensor gets, we'll call it saturated or full of mercury. There is no regeneration per se for the atomic fluorescence or the atomic absorption. You just have to allow the instruments to clear the chamber so you're ready to go. Now on the gold film sensor, regeneration, the sensors actually, it heats up. So the sensor gets hot, takes about a minute to get it hot and burn off all of the mercury molecules. But the gold film sensor is sensitive to temperature. So you need to allow that instrument to cool down because there again, you have your reference gold film side and then your side that's actually doing the testing. Well, the one that's doing the testing got hot where the reference one did not. And so you have to allow it to cool down and become ambient or equal. Design, the atomic fluorescence is very durable. The gold film sensor, again, no real, everything is pretty stable in both of those instruments. Whereas the atomic absorption, there again, if the mirrors get out of whack, you're out of cal and needs to be set back. It's pretty lengthy pretty entailed to redo those mirrors inside of there because they have to be exact to shoot that ray of light from one mirror to the next. Detection limits. There again, the atomic fluorescence will go down as low as 50 nanograms. The gold film sensor will go down to 0.5 micrograms per meter cubed. The atomic absorption actually goes down way lower. They're going down to, looks like 5 nanograms per meter cubed. So that's kind of their claim to fame. But there again, you do have those issues with interferences, humidity, and mirror movement. Portability, of course, the gold film sensor and the atomic fluorescence are much lighter than the atomic absorption, 15-pound unit. Oh boy, I'm done already. I want to go back and just see if I've missed anything before we take questions. And that would be right.
If you want to look at everything.
Where is, oh, there it is. Okay, we talked about that. Talked about the operation. Okay. So, other applications, I didn't touch on everything here. There are so many out there where you're looking for mercury vapor in air. One that has come up, I would say within the last, well, it's just come up a lot lately, I should say. I know it's been there, is the gym floors in schools. Apparently, they use mercury to level gym floors, and then when they have to replace them or tear them up, there seems to be a real concern for the amount of mercury vapor that is going, off-gassing as the workers are tearing out gym floors at high schools and colleges and things like that, or even in the professional ones too. Let's see what else. Landfills is another one that they monitor for mercury vapor. Some of the landfills have recycling places, and sometimes they'll just go through the mine, the pit itself, and they'll go around the border and just check for mercury vapor. Hydrogen sulfide as well is a bigger one at landfills. Let's see, what other areas? We talked about the autism being a big one for mercury vapor. Well, the medical manufacturing, medicine manufacturing plants, way back when they did vaccines for smallpox, measles, things like that, they would actually put mercury in those vaccines, and the reason they did that was it acted as a preservative in those vaccines. So that's how a lot of I guess kids, or they're blaming autism on those vaccines. Nothing's been proven, but there again, that's just another example of how it was used in the past, and they don't do that anymore. So let's see, anything else? Yeah.
Joe, I've got a couple questions that have come up.
Okay.
What is the data file format that the instrument presents?
I believe it spits out a CSV.
Okay, so you can export to an Excel file.
Yes. It comes out. Yeah.
No. So when you download the information onto the flash drive, you put it back. You put it in your computer, and then you can export it into Excel.
Okay. I've got one other one. It says, can you touch upon the sampling methodology?
Touch upon the sampling methodology on both instruments, or?
He doesn't specify.
Well, let's see. Basically, all the instruments that we talked about will take a sample in air. You want to be in a place where you suspect mercury will be there, and have the instrument take those readings in survey mode until you get a hit, and then at that point you do want to back it out. So because in survey mode it's not as accurate as it is in like the regular just testing mode. The survey mode is just kind of meant to, okay, I'm getting a hit here, I've got mercury, now I got to find it.
Is there a zeroing process that you go through before sampling, or any sort of calibration to be done?
No, the instruments usually you turn them on. You don't want to take the instruments, not so much on the 505 on the fluorescence. Temperature is not a big deal, but on the mercury it is. So you wouldn't want to take your mercury vapor analyzer with the gold film from a hot car to outside cold, or vice versa. It has to acclimate to the air that it's sampling, and that's more on the gold film side. With the other instruments, not so much. Temperature doesn't really affect them too much, although you could not go to the top of a coal-fired power plant and grab a sample coming off of those stacks because it's hot, and it would ruin the inside of the instrument. There are other ways to actually do that, where you have to grab a sample, cool it down to the spec that the instrument calls, the temperature-wise. That being said, usually coal-fired power plants, they have automated type systems already, in those stacks. This is meant more for going around maybe a facility or into a building to check for mercury, for safety for employees and things like that.
Okay, looks like I'm getting a bunch more questions here. Let's see. What are the temperature specifications for the different instruments?
So the gold film unit would be 0 to 45 C. The atomic absorption and atomic fluorescence would probably be very similar. And what's that? Oh, 5 C to 45 C.
They're not too much different.
So yeah.
We've got one that's pretty specific here. What are the OELs? I'm not sure. For OSHA, ACGH, EPA, and NIOSH.
Okay, so there's our exposure limits, or recommended, from OSHA, from NIOSH, from the Mine Safety Health Administration, EPA, and so forth.
Okay. Oh, he says, great, thanks. Okay, and I got another one here. What's the sensor life on each of these instruments?
So the sensor life on the atomic absorption and atomic fluorescence, we haven't had a PMT go out. The only thing that's gone out for us is the bulb, and we did horrendous testing on that, and I believe they got up somewhere around 500,000 tests before the bulb went out. Now, that being said, I remember we sent one out, and the bulb went out on some guy just left right away. Of course, it was still under warranty, so we replaced it. But usually they usually don't go out, and they'll test those things when they come back for an annual cal. Sensor life on a gold film sensor, there again, it depends on how, we have a mercury analyzer that you can put outside, like out in the field on a landfill or something, or in a building, to manufacture, to measure mercury in air. And we recommend for that, using it 24/7, we recommend sending it back quarterly just to check the sensor. Now that's doing regens, once a day, sometimes twice a day. That's having the instrument on all the time and taking a reading every 15 minutes. The tighter you get, like let's say you drop down to 10 minutes or 5 minutes, the more apt, I guess, you're going to throw that sensor out of cal. With that being said, it depends on how often you're using it. Some people have had sensors out there for 3 or 4 years. Some people burn them out fast. They burn them out within 18 months or so. I always recommend, if you're buying a unit from us, send it back while it's still under the 1-year warranty. Send it back in 10 or 11 months and say, I think it's out of cal, do a recal on it. We'll do a free recalibration, and you'll get a new calibration cert for that instrument. And you should be good to go for another year.
Okay, while we answer the last couple of questions that are coming up, can you go back to the slide that shows the detection limit for each instrument?
Okay, there you go.
Another question, can any instrument be used to sample in an isokinetic mode?
I don't know. I'm not sure what that is.
I think we'll have to get back to that one.
Yeah.
I'll ask Jim.
Okay. Isokinetic, okay.
And then do the optics on the spectroscopic instruments need routine cleaning? Do mirrors and lenses accumulate dust over time?
Yes. Yes. It's more so in the atomic absorption units. When they send them back for recalibration, they're going to put it on the cal bench, and if it's not hitting the number, then that's when they start going through it. So yes, like I said, dust is one, and humidity is another one, and then of course if the mirror is out of kilter a little bit, that's another deal. So they do have to open the chamber or the box that's inside of the instrument to fix all of that. It's kind of painstaking.
Go back to the isokinetic question. He's asking if it can be used in stack sampling. Imagine temperature would be a big issue there.
Yeah, it can be used in stack sampling if the sample of air that you are testing, it falls within the range. So I know stack gases tend to get really high. So you would have to cool it down so that you are not, you're not going to ruin the instrument or, the PMT or what, some of the internal parts of the instrument. Because, well, especially the gold film sensor, it has Tygon, small Tygon tubing inside. If it gets too hot, it's gonna create moisture in that tube or even melt it. And then you're going to have to send the instrument back to be repaired.
And unless there's any more, I think we're up to the last question. What is the cost for recalibration?
On the gold film sensor, it's about $550, and the atomic fluorescence about $575. Now, if the gold film sensor needs a new sensor, a gold film sensor, it jumps up to $1,200. But the $1,200 would include the recal and the sensor itself.
Okay. All right, I think that'll conclude the presentation. Joe, thank you very much. If anybody has any other specific application questions, you can give me a call at 866-RENT-EHS or 866-736-8347. I can also be reached at matt@raecorents.com. If you want to know any more about the technology supply, please follow us on social media. We put out a lot of good technical tips on my blog at blog.raecorents.com. You can follow me on LinkedIn and Twitter, and we record all these sessions, so they'll be posted on our website and also on YouTube. There are some topics you'd like us to cover on our webinar, please send me an email with the subject. We have access to a lot of product and process specialists, and we can get hold of them and set one of these up. At this point, I guess if there's no further questions, we'll conclude the presentation, and thank you all for attending, and thank you, Joe. Have a great day.
Well, if there's any questions, get them to Matt, and I'll send them to him, and we'll get them over.
Okay. All right. Thanks. Have a great day.
All righty.
All right. Bye, everybody.
Bye.